Hello, everyone. Am I audible? Okay, cool. So how's everyone doing? I know it's the last talk of the day, and I'll try to keep it quite short because we have a round panel which is coming up. Being here in Italy reminds me of Shakespeare, thinking about Romeo, Juliet, Othello, and numerous plays which Shakespeare has written. There was one common thing in those plays where he has shown that men of excellent character have fallen because of small vices. No doubt, Shakespeare was a visionary person. If I correlate it with Android world, it's kind of similar too. Users like an app which is smooth, seamless, and has a snappy experience. But what would happen if your app starts dropping frames? What happens like when you're using something and it crashes suddenly? I'm pretty sure that the next time you would choose an alternative if that snappy experience, like if that sluggy experience actually continues. And that small pitfall in experience is that small leak which can sink a great ship. So let's start today's journey. Before moving ahead, let me introduce myself. I'm Ayushi Gupta, currently working as a senior Android engineer with Zalando. I'm based out of Berlin. It's my first time in Europe, and I'm really liking it so far. Prior to this, I was working with numerous companies like GoTo, which is an Indonesian multi-service platform, Disney Plus Hotstar, which is India's leading OTT platform, with a record of 25.3 million concurrency. And I'm really proud to be part of that journey of scaling the Exo player to that concurrency level. You can find more details about this journey at my website, and feel free to connect with me on Twitter. Let me use this opportunity to introduce Zalando to all of you. I know most of you would be knowing Zalando. Zalando is a leading online fashion platform with more than 49 million active customers based across Europe. In 2021, we delivered successfully 250 million orders in 25 countries based across 140 nations. We had more than 7 billion website visits, and we present to our users a huge variety of 6,000 brands. So the scale is pretty huge. So after a bit about me and my current organization, let's start today's journey to save the sinking ship. There's a saying, if you know it, you can deal with it. So why not let's start about knowing a bit about how is the Android memory structure looks like. Most of the Android apps execute on the top of ART, that is Android runtime, which actually replaced the deprecated one, Dalvik Virtual Machine. Both ART and DVM have a common similarity share with JVM, that is Java Virtual Machine. ART uses two separate memory spaces. If you look under the hood, these memory spaces are stack memory and heap memory, and they both combiningly form a major chunk of your device RAM. Let's just take a step closer to stack and heap. What is there in stack memory? What does it comprises of? Stack is majorly used for the execution of a thread. It contains method-specific values, which are kind of short-lived, and it contains references to the objects which are created in the heap memory. So stack is all about static memory allocation. Stack is kind of pretty fast, but how is that possible? That's because of last in and first out execution. So now the question comes, how much is the limit for stack memory? So like memory is directly related to your app performance, so obviously Android system will put a limit on the top of it. In the case of ART, this limit is somewhere around 1 MB. So that is pretty small. Now what happens when you will hit that limit? Obviously, the OS will give you an error. And in this case, it is the stack overflow error. So this was all about stack memory. Now let's just evaluate heap memory as well. So like as we discussed, stack is used just for the execution of a thread, whereas heap memory is all about dynamic memory allocation. Whenever you create an object, it's going to be first created in the heap memory. And the reference to that object will be kept in stack memory. So that's all about dynamic memory allocation. Whenever you create an object in a heap, it is accessible globally. That object will be accessible across the entire app. So what does Android system does? Android sets a hard limit on this memory as well. And this limit is directly proportional to the device RAM. And if your app hits this heap limit, you will gonna get an out-of-memory error crash, and your app will terminate. So now let's just see how does Android ecosystem gives you a smoother experience. We have a superhero in Android ecosystem, that is garbage collector, which is making sure that all the objects that you're creating are automatically cleared. When an object does not contain any hard reference to it, will be automatically cleared by GC. In short, whatever is equal to be null, it has to be cleared. And that's the job of this superhero, garbage collector. It's the time now to bring that leak in the picture, which is capable enough to sink a gray ship. That is memory leak. What is a memory leak? A memory leak is just an object whose memory was not collected because there was still a hard reference to it in memory. This means that garbage collector was not able to do its task. That is, GC is not able to take out the trash. So let's just see what happens in that particular process. When you keep using the app, and let's say if you have some memory leaks and a lot of objects created. So first, a short GC will come in picture. You will not actually see what is happening with the short GC because that is going to happen on a separate thread. And the pause is around like 2 milliseconds to 5 milliseconds of pause. But still, if there are any hard references and you have some hidden memory leaks in your code, a big brother will come in picture. And that's the large GC. And when large GC comes in, it's like a stop the world call. Because large GC will start its execution on the main thread. And during this moment, your app becomes seriously unusable. And the pause is significant. It is somewhere around 50 milliseconds to 100 milliseconds of pause. And even after doing all of this thing, if still you keep on using the app and the limit is hit, and none of the big brother, small brother can do their task, your app will crash. And this is the time you're going to get an out-of-memory error. So now we know what a memory leak can do to your app and your customer experience. Lesser the garbage collector has to run on the app, the more the smoother app experience would be. So now let's just try to take a step ahead and try to detect these memory leaks in our code base so that we can take a step towards better user experience. I'm pretty sure as soon as everyone in the audience heard memory leak, the first thought would be leak Canary, which is a memory leak detection library, or maybe memory profiler, which comes handy with Android Studio. Today, we're going to see what extra we can do with leak Canary. So what is leak Canary? Leak Canary is a memory leak detection library. What makes it unique and special? It's the knowledge of the Android internals. It's the way the leak Canary hooks into the Android lifecycle, which gives it a unique ability to drill down to that level where it can give you the reference, what is happening inside your code base. That will actually help you to evaluate your ANR freeze, and most important, out-of-memory error crashes. Leak Canary will help you to find and fix these memory leaks during your development cycle itself. It even generates memory leak reports for each session of the app. So this is what Leak Canary does for you. Now the question is, what's happening under the hood? Under the hood, it's actually doing 4 tasks for you. First is the retained object detection. Next, dumping of heap. Then comes heap analysis. Last, but the most important one, categorization of those leaks. Let's just take a step closer towards retained object detection. As I mentioned, Leak Canary hooks into the Android lifecycle automatically. When it hooks automatically, it can detect for you when your activity is getting destroyed or when your fragment is getting destroyed. Isn't that good enough? Now, when it is already hooked into the Android lifecycle, it can actually check whether the objects are getting cleared or not, whether the objects are meant to be cleared or not. So it first receives all the dead objects for you. Then it passes all such dead objects to Object Watcher. What does Object Watcher do? It will do, first, it will try to maintain a weak reference for those objects. Now, once it has a weak reference for it, it will actually wait for 5 seconds. When it waits for 5 seconds, it will try to execute GC on the top of it. When it will try to execute GC, it will see whether it is actually able to clear all such objects or not. And within that wait time, if it is not able to clear all such objects, then it will consider that object as potentially leaking. But it is potentially leaking. It might be maybe the object didn't clear for 5 seconds. So what does Leak Canary do an inch extra for you? It will keep the count of all such retained objects for you. It has a threshold. This threshold is automatically set as 5 when your app is visible. And this threshold is set to 1 as soon as your app goes in background. So I think I have to use my laptop only. So it will try to check the count of those all retained dead objects. If the count is more than threshold, then it will trigger the heap dump. And when the heap dump is triggered, this is the moment where you will actually see the pause. When the count of dead objects reaches the threshold, the Leak Canary will dump the entire Java heap into a .h file, which is nothing. It's just a heap dump, and that is stored in your Android file system. And during this process, your app will be frozen. I think everybody would remember this toast if they are using Leak Canary in their app, that it's dumping memory to investigate leaks. Now the question comes, you have the heap dump. What to do with it? So Leak Canary starts analyzing that heap dump. How does it do that? It's done by Shark. What is Shark? Shark is a new standalone library which does smart heap analysis reports for Kotlin. Shark will try to locate all such retained objects in the heap dump. And then it will start finding the path references of all the dead objects, which actually led this object to be dead. And then it will create a signature for each leak trace. One interesting feature about Leak Canary is the signature-based grouping. So Leak Canary automatically does grouping for you. Isn't that cool enough? I think that will actually help you to recognize, yes, this particular signature is leading to the same bug. If you have a closer look at the leak trace, which is nothing, which is just the hash of the concatenation of each reference, which is actually suspected to cause the leak. That is references like underlines you can see in your leak trace. So if something is underlined, you can see that, yes, this guy could be potentially leaking. Now we have all the data that we could extract from our leak trace. But the question is, are we going to fix everything that is coming in the leak trace? I guess no. All the Android apps uses a lot of third-party codes. For example, it may be a library for, let's say, an image loading library, or let's say something else. And fixing of the leaks which are coming from that third-party code might not be in your control. So Leak Canary does categorization for you. It extracts out what is coming from applications and what is coming from libraries. I think this is pretty cool, so that I can focus what is coming from my own app. So now you have seen what Leak Canary capabilities are and what does Leak Canary gives to you. Now it's a time to think about, is there something better than Leak Canary? Or should we consider some better option? Or is there an upgrade available? I think, yes, there is an upgrade available. And if you have not considered it, you should consider to upgrade to Leak Canary 2. But I know everyone would be curious why I should upgrade to Leak Canary 2. Here are some of my reasons. First, Leak Canary 2 is a major rewrite with the internals returned to 100% Kotlin. Not only that, this particular library can detect multiple leaks in one analysis. I think that makes it pretty fast. And not only that, it can be grouped per leak type. What I personally like the most is the simplified API configuration. Now, I can access to heap analysis data so that I can play around it. And last, but most important one, is the easily accessible heap analyzer, which itself is re-implemented from scratch. And it uses 10 times less memory. So these are some of my reasons to upgrade to Leak Canary 2. Now let's just go a bit of flashback. Like if you remember, if you have to add Leak Canary in your code, this is how you have to do it. So you can see there are a lot of dependencies that you have to add when you have to add Leak Canary in your code. But now, when you'll upgrade, it looks something like this. Worth noticing over here is the debug implementation. It's just one line of code that you need to add in your code base to update to Leak Canary 2. There is no more Android no-op artifact for release builds. So there will be no more referencing in release builds. One more thing you'll notice here, that it does not depend on support libraries anymore. It even does not depend on Android X either. Even the detection of fragments is now automatic if you have Android X fragment dependency. Isn't it a way cleaner approach? I guess so. Earlier, if you remember, when you have to wire Leak Canary in your code base, you have to do all of this boilerplate code. Quite huge. You have to check whether it's in the app is in the analyzer process, and then you have to install that. But now, you don't need any of this code. It auto-installs itself. Even, there is no need to call Leak Canary is an analyzer process, because by default, Leak Canary 2 executes in the main thread. So this code is no more needed. Any feature development is incomplete without adding testing to it. So what does Leak Canary gives you for testing? Now, there is a dependency for testing as well. The dependency is quite simple. That can help you to detect memory leaks in your UI testing stage. It looks something like this. You just have to add this Android test implementation. Now, you can wire Leak Canary in all your test classes. You just need to add this particular function in your test classes, leak assertion.assert no leak. It looks something like this. You just have to add this particular function. If any retained instances are detected during your UI testing stage, it will automatically give you no leak assertion failed error. And when the error comes, obviously, that particular test case will fail. Isn't it cool that you can now wire and check whether the memory leaks are there in your UI testing stage? So this is all about adding it in testing. But just imagine if your test classes are quite huge. I think none of the developer would like to write this particular line in all such test classes. So you can now even add test rules. It looks something like this. You can just add this particular snippet of code in your test class, and it will automatically trigger the function which we have seen at the end of each test case. So quite a cleaner approach. You can have your base test classes and let it handle it for you. So this is all about testing. Now consider a scenario where, let's say, you are trying to fix a bug and you want your pipelines to be green. How to avoid that situation? Is there something available that would, for the time being, will let it be executing the test case? Yes, there is @skip leak detection. This particular annotation will gonna disable leak assertion.assert not leak in that particular test case. So now you're free to fix your memory leaks in testing stage as well. So now we have our tools kind of ready. It's time for the quest of cleanup. Before taking a step ahead, I just want to give a normal developer strategy outlook. How does a normal developer starts working? Obviously, it starts with getting a product requirement, and like you get it, you clarify it, and you start development for it. And once the development is complete, you'll start with your own round of developer testing. I guess if you have toggles around leak canary, this is the time you're going to turn the toggle off, because you don't want leak canary to mess it up with your testing phase. You want to meet a deadline. So when this is done, obviously you're going to raise your PR for review and then submit it for QA. And when everything is cool, it's good, it's green, you're going to merge it into main branch. The question is that during this entire process, are you going to go and see what's happening in your leak canary app? I guess no. None of the developer would go and see what's coming in the leak traces. So why not do something that will, by default, does the leak canary every task for you? You don't have to disable the leaks, or you don't have to go and see in the app like what's happening. So this is what I did for leak canary 2 implementation. First, I started with analysis upload listener. If you remember, we were talking about simplified APIs that are coming in leak canary 2. So now you can add an event listener for the heap analysis process. Whenever the heap analysis is succeeded, you're going to get a call back. And here, when I get the call back for heap analysis is successful, I'm going to trigger a service. I think you should see over here there is something called as leak canary upload service. But how to notify leak canary that we are adding a listener? So you need to update your config as well. So leak canary 2 has simplified ways of updating the config. It's just quite simple, one line of code. So now we have wired the config, we have updated, we have a listener. What is this leak canary upload service? What is going to do for us? First, we're going to evaluate the heap analysis success data in this particular service. Obviously, you want to extract out application leaks and extract out library leaks as well. For example, you can just keep on side for the library leaks, but you want to focus what is coming from your application. Not only that, you would like to transform the leak trace data. You might want to add some, let's say you want to add some code owners, or let's say some additional payload information in that trace data. So all sort of transformation, we're going to do it in our service. Last, but the most important one. Since I'm talking here about visualization of leak trace data at a better scale, and most importantly, like it happens under the hood, you don't have to worry about it. So I want to preserve the format so that when I see the data, I could actually go and navigate in the code base from where this suspicious thing is coming in. So we have to preserve the data format. So Leak Canary upload service contains a custom stack trace builder for you. So this is what we have in Leak Canary upload service. Now the question is where to visualize it. Any suggestions, any ideas? What tool you will think of to visualize? The same question came to me. Then I thought, why not I use Firebase Crashlytics? Why not I use Firebase Crashlytics for the visualization of leak trace data? My reasons were pretty simple. First of all, I guess most of the Android apps over here are using Firebase Crashlytics nowadays. It's pretty lightweight. And it's almost a real-time crash reporter. Something happens on the app, it's almost a real-time information that comes on Firebase Crashlytics dashboards. It's quite easy to track. It becomes very easy for me to track and go and see and analyze the format. It becomes easy to prioritize as well, because you can see how many developers are actually affected by this leak trace. So you can convince your manager to say, hey, you're working on this particular leak trace. And this is also an interesting thing, additional payload capability, which comes in Firebase Crashlytics. You can bundle any of the information that you want on Crashlytics along with your stack trace. So now let's just try to wire your Leak Canary upload service with Firebase Crashlytics power. Since we are playing everything in the debug version of the app, we're not going to mess with the production numbers. So we are quite safe. We will start recording leak traces as non-fatal exceptions. I'm going to track some affected developers, which are coming as the numbers. OK, this particular leak non-fatal exception has been recorded for so-and-so users. I can actually go and add the code owners. It's very, very easy. You know the signature, you know the file. And based on the file history and the file naming conventions, you can know who is the code owner for this particular piece of code. When we have added the categorization on the Firebase Crashlytics itself, we can categorize whether this is an application leak or this is a library leak. And after all of this, it becomes pretty easy for me to prioritize. So if we talk about code, it looks something like this. I have a heap analysis which contains application leak, and I start recording the exception in Crashlytics. And obviously, the worth noticing over here is the application leak exception, which is our custom stack trace builder, which is going to do everything for you. It's going to get the code owner for you. It's going to make sure that the data format is preserved. So this is what I did. I think that's my cute little app which I made during this particular process. And when there was a leak trace that was recorded, it got automatically updated, uploaded on my Firebase Crashlytics dashboard. And on this, I can actually visualize whether this particular line of code is leaking or not. So the stack trace is prettily preserved. If you recall our conversation around adding leak trace information in your UI testing, so we can have a custom heap analysis reporter for our UI testing as well. Leak assertion.assertNoLeak delegates a call to a global detect leak assert implementation. And you can actually customize that implementation by adding this piece of code. You can update it. And when you update it, you can wire the same service which we have created in your testing files. And when you do that, obviously your test is going to be executing on your CI/CD pipeline. So if anything goes wrong on your CI/CD pipeline, and all such vulnerabilities could be recorded on your Firebase Crashlytics. So now our tool is ready with visualization embedded in it. Obviously, every tool has a scope of advancement. So here are some scope of advancements that we could think of. First, code owners with trace. What I did was just like, we work in pillars, and so what I did was based on pillar names. You could actually drill down and try to tag the user who has created that particular piece of code. Not only that, Firebase Crashlytics gives you an option for velocity alerts. So whenever a new non-fatal exception is recorded for you, you can get a velocity alert. Ki, hey, this particular thing has leaked for you. Not only that, Firebase Crashlytics has webhooks to integrate it with Slack. So you can have almost real-time notifications coming to your Slack. And this one I really like the most is all about Jira integration. You can automatically create webhooks and create Jira tickets. So it's on you when you want to prioritize and fix that particular memory leak. So this is all about the tool, the things that we could be created. Now let's just think around how we can fix the leaks. Memory leaks gonna cost you a lot in terms of your app performance, and in turn, user retention too. So here are some do's and don'ts that you can incorporate in your coding style to avoid leaks. First, avoid using static variables for views and context-related references. Avoid passing context, like be careful when you're playing around with context. Be careful when you pass context-related information and references to singleton class. Take care of context specially. For example, when you're passing activity context or view context, when you're showing toast or snack bars, think around using application context. Be careful with using inner classes and anonymous classes. There is a reason why I'm saying this, because inner class contains an implicit reference to its outer class. And the same is with anonymous class too. Since the reference is hidden, you might not know how it's looking for you. So be careful with inner classes and anonymous classes. If you have listeners, make sure that you unregister them. And here are some of my do's, which I usually do during my coding style. I usually use weak references for context-related stuff. Do a cautious programming. Every developer should know what this particular piece of code could lead to. Try to incorporate a habit of regular check on the ANRs. Google Play Console contains good information around ANRs. So once in a while, have a look on your Play Console. And try to use delegate referencing to DI. Anything which is related to context, it's better to use DI for that, so that once the scope is gone, it gets automatically cleared. These small steps, while building the app, can help you to deliver high-performance Android apps. Detecting, visualizing, and fixing the leaks will not only make your app performance smoother, but in turn, it will slowly turn you into a better developer as well. Leak detection can tell you where there are bad coding smells or where there are bad coding patterns which are incorporated in your code base before they get baked so much into the app where they haunt you to fix it. So just think around these leak detection while you're developing. No doubt, development is an ever-going journey. But these small things can help you to save your ship from sinking and can set the course for selling it high. So that's it for today. Let's give this session a wrap. Thank you, everyone, for being patient listeners, and happy coding.
Thank you so much, Ayushi, for your talk.